Welcome back to my English math series. As I mentioned in the previous video, the point at issue of this lecture is to discuss further about inverse proportion. When y is directly proportional to the inverse of x, y is said to be inversely proportional to x. To define this relationship, will remind you of direct proportion. Y is said to be directly proportional to x if y is equal to the product of x and a non-zero constant k. Thus, if y is directly proportional to 1 over x, we have the equations y equals to k multiplied by 1 over x, or equivalently, the product of x and y equals to k. And that equation is used to describe inversely proportional relationship of the two variables x and y. If the product of two variables x and y is equal to a non-zero constant k, these variables are said to be inversely proportional to each other with proportionality constant k. Now, I would make a comparison of direct and inverse proportion. While in direct proportion, the ratio of the two quantities remains unchanged. In inverse proportion, their product is a constant. Next, in case that y is directly proportional to x with proportionality constant k, x is directly proportional to y with proportionality constant 1 over k. However, if y is inversely proportional to x with proportionality constant k, x is inversely proportional to y with the same proportionality constant. What's more, while direct proportion is used to describe the relationship between two quantities growing by the same scale factor, in inversely proportional relationship, as one gets bigger, the other gets smaller by the same rate. Furthermore, we can easily prove some relations of the three quantities. If A and B are inversely proportional to each other, and B is directly proportional to C, A and C are inversely proportional to each other. Seeing that B is directly proportional to C, there must be a non-zero constant K1 such that B equals to K1C. Also, A and B are inversely proportional, so there is a non-zero constant K2 such that the product of A and B equals to K2. Substituting B by K1C, we have A multiplied by K1C is equal to K2. Equivalently, the product of A and C is equal to the ratio of K2 to K1, and the ratio of two constants is of course a constant. Therefore, A and C are inversely proportional. Similarly, we have if A and B are inversely proportional and B and C are inversely proportional. A is directly proportional to C. Now, let's see how to solve a problem related to inverse proportion. The table shows values of the two quantities. If y is directly proportional to x, the ratio of each column is the same as the other, while their products are equal to each other if x and y are inversely proportional. Now it's time to practice. Exercise 1. 20 workers can build a house in 16 days. The question is, how many days will it take for 32 workers working at the same rate to build the same house? It can be seen that the more workers recruited, the less time it takes to build the house by the same scale. As a result, the number of workers and the time it takes to build the house are inversely proportional to each other. Now, let x days be the time it takes for 32 workers to build that house. We have the product of 20 and 16 is equal to 32x, and x is equal to 10. In conclusion, 32 workers need 10 days to build the house. Exercise 2. A rope makes 260 rounds of a cylinder with base radius 20 centimeters. How many times can it go round a cylinder with base radius 26 centimeters? The larger circumference of circular base of cylinder is the less time that rope can go round. Thus, the number of rounds and circumference of circular base are inversely proportional to each other. Besides, circumference of a circle is directly proportional to its radius, because circumference of a circle is the product of 2b and its radius, and we know that b is a constant. Thus, the number of rounds and the base radius are inversely proportional to each other. And let n be the number of times the rope can go round a cylinder with base radius 26 centimeters. We have the product of 260 and 20 is equal to the product of n and 26. Now we have n is equal to 200. In a word, if the base radius is 26 centimeters, the rope can go round the cylinder 200 times. That is the end of the video. You can click the subscribe and like button to motivate the creation of more videos teaching math by English. Thanks for watching.